Hi everyone. In this lecture, we're going to explore the responsibilities of an engineer in terms of service to the global community and humanitarianism. This is Professor Uzbil. You might remember me from the lecture about creativity, the science of creativity. So today we're going to talk about social responsibility. What does social responsibility mean for an engineer? Now, social responsibility is an ethical framework and it suggests that an entity, whether that's an organization or a person, has an obligation to act for the benefit of society at large. This is a duty that every individual has to perform so that we can maintain a balance between the economy and the ecosystems. Now, a trade off actually might exist between the economic development in the material sense and the welfare of the society and the environment at large. As difficult as it is, as engineers, it means that we are responsible for establishing an equilibrium between the two. This is not just the responsibility of organizations or businesses, but the responsibility of citizens to perform this duty. Now, we can perform this responsibility in a passive or an active way, right? For example, if you're working at a corporation and you have to comply with the rules and regulations that have been created by the Environmental Protection Agency to make sure that you're not polluting the environment. So you can participate in a passive way just by complying with the regulations and not doing anything more. A proactive way, an active way to participate would be to actually talk to the people, to the clients and the customers, or to the people who are impacted by these pollutants, to make sure that you take actions to make their lives better, to make sure that what you're producing or the byproducts of what you're producing are not impacting their lives in a negative way. And I would say as an engineer, our responsibility is not just to be passive rule followers, but to be active participants in making sure that our actions impact the environment in a very positive way. Now, taking this extra step requires a lot of work. It requires an understanding of people's needs and wants. It requires an appreciation for different parts of society and different kind of communities that you might not be engaging with on a daily basis as part of your profession or as part of your personal life. It requires an understanding of very basic human psychology, because that's what everything comes back to. In order to protect the environment that we live in, we need to understand people's needs and how to address those needs as engineers. So it is morally binding that we act in a way that minimizes the adverse effect of our actions on those immediately around us. So let's take that one step further. So when we talk about rules and regulations, some people argue that the government should not be involved in regulating everything in our lives and should leave us freedom, right? And some people say, well, if you leave it to voluntary action, then not much will happen. Studies actually suggest that social responsibility that is taken on by individuals and companies voluntarily is much more effective as opposed to mandated by the government. Now, I'm not arguing a certain political point here. There are rules and regulations that need to be put together by the government so that everybody complies to certain basic rules. But we also have responsibility as citizens to raise our voice and to bring up these concerns. And especially as engineers, because we understand science and technology so well, we might be able to interpret the repercussions of certain technologies and how it will impact the society as opposed to somebody with a non-technical degree. So we need to make sure that we live in an equilibrium between a company's needs and the society's needs, and that we develop solutions, products, and inventions that serve that equilibrium. Now, as engineers, we're sitting at the cusp of society and solving problems. There are societal problems, needs, and wants that require the use of technology and science. And we as engineers actually translate this technology and science into these solutions. Now, I differentiate between problems, needs, and wants, and here's the reason. For example, if you're suffering from a disease, that is a problem. That is a medical problem that needs to be solved. At the same time, we have very basic healthcare needs. Even if you're not sick, even if you're not suffering from a disease, you have basic healthcare needs that need to be taken care of. As people, we also have wants. We want entertainment. We want social interaction. Especially after iPhone has come out, there are all these applications that provide entertainment or serve different needs for people. In those cases, not just as an environmental engineer, not just as an engineer that works in healthcare or public health, we have a responsibility. If we're designing a video game, we still have a responsibility that our product does not have a negative impact on others. That's why embracing the social responsibility as engineers is so important, because we are the ones who translate the technology or science into good use or bad use. Now, let's take a more extreme example. Weapons, or weapons of mass destruction. People who developed the technologies that enabled basically the production of these weapons did put it together in order to protect their nation. They were serving their country or their community so that the military can protect the nation by using these weapons. Now, unfortunately, these weapons end up in the hands of people who are not using it as a defense, but are using it as an offense. These weapons are responsible of civilians being killed. These weapons get into the wrong hands through illegal trading and help groups of people take advantage of civilians and perform bad actions. Now, as an engineer, when we develop these solutions, we have the responsibility to think about that and to provide and put in certain rules or safety requirements that will prevent those bad actions from happening. The important thing is we cannot wash our hands and say, I developed this for a good purpose, people should not use it for bad purposes. But as an engineer, we are responsible in educating the society about the use of these technologies. Another place where this plays out is the petroleum industry. As an engineer working in this industry, you have to make sure not just to maximize the company profits, not just help the company return shareholder value, but we have the responsibility to make sure the environment is protected. Maybe you can work as an engineer in that area and also participate in non-profit organizations, making sure the environment is protected, making sure that we produce energy in a way that's socially conscious, to make sure we produce energy that's affordable for people, and to make sure we produce energy that does not impact the environment in a negative way. Now, I want to show you an organization that serves an immense need in the developing countries. This organization is called Engineering World Health. I've had the pleasure of working directly with the founder of this organization, Bob Malkin. He's at Duke University, but this organization has chapters at many universities around the nation. And this video now will talk about the Engineering World Health Summer Institute and how engineer students actually work on saving lives in the developing world. So please join me in watching this video. A bit of a technical problem.
Hospitals in developing nations are working overtime. Medical infrastructure is weak. Resources are in short supply. Millions of dollars worth of medical equipment is donated every year to the developing world. Much of it goes unused. The problem is, equipment breaks. Frequently, there is no one who knows how to repair it. Instruction manuals, if any exist, often need translation. What cannot be repaired is put into storage and wastes away. Solving these problems takes skill and ingenuity. Engineering World Health and its Summer Institute program sends students with backgrounds in math and science to developing countries to fix machines one by one. Parts are scarce. The students must use imagination and applied skills to create inventive solutions to repair medical equipment.
Opening up the first piece of equipment and looking at the first circuit board, I was just completely intimidated. But after a while, we got into the swing of things, and I feel like I made a huge difference.
Students take all the theories they've learned in the classroom and implement them in the most challenging of real-world hospital applications. They drill and solder, thread and test. Some of the fixes are simple, some are complicated. All of the repairs can save lives.
This is an electrocardiogram and blood pressure reader that we fixed. It took us 3 days to take it apart piece by piece until we found a break in the circuit due to corrosion, and it took us another day to put it back together. But now that we finally see it working in a hospital, it makes me feel really good about what we're doing here.
My name is Dr. Osvaldo Mercado, and I have worked with Engineering World Health for almost 10 years. Each year the students come, they make a major impact by fixing some hospital equipment. We value our relationship with the students and Engineering World Health.
I'm holding a newborn baby here, and this is really exciting. I helped translate the English manual into Spanish for this infant radiant warmer. Throughout our month here at this hospital, we've definitely had a lot of interaction one-on-one with patients. So not only do we get to work behind the scenes and work on the infrastructure of this hospital, but we get to see firsthand the impact it makes when we see that our patients are actually using the equipment that we have dealt with, and to see the effects that they have on their lives and on their health.
The summer program is 2 months long. The first month focuses on language and cultural understanding. The second month is spent by students working at hospitals partnering with Engineering World Health. Students fix medical equipment, which immediately raises the standard of care at a beleaguered hospital. A change that can last for years. And as is often the case, the ones giving receive the greatest gifts. Students develop traits they will carry throughout their careers and lives.
Creativity.
Endurance.
Innovation.
Service.
Humility.
Resourcefulness.
Dedication.
Transformation.
Now, what a better way to change the world than starting by saving lives. So, as socially responsible engineers, we're not just technical service providers or technical inventors. This is what I wanted to show you through this video. But we are professionals that actually lead to change through the understanding of the human form through understanding of the cultural and the environmental effects of what we do and the societal challenges that people face. You've seen that the work that these engineers do, a lot of it involved cultural understanding. It could be as simple as translating a manual that people were not able to understand to use a machine, or it could be as complicated as maybe communicating or teaching somebody to repair and fix that equipment, or to repair and fix the equipment yourself when you don't have the tools that you are used to in your lab at the university or in your lab at the corporation that you're working on. The third world setting and the developing country setting provides different challenges that require the engineers to be not just socially responsible, but you heard the traits that the students were talking about. You got to be creative. You got to be resourceful. You have to be a humanitarian. You have to understand the basic people needs. You have to come up with innovations, and you have to accept the challenge of caring about more than the technical challenge at hand. Now, how do you incorporate this in our professional and our personal lives as engineers? There are environmental and human considerations that have to be in place so that we can provide solutions for people in need. And designing in a global economy requires the understanding of different cultures and maybe also their languages. The product design teams must incorporate these elements very early on in their product design process. We're gonna see another video actually that addresses that problem. And it is our responsibility to bring the latest technologies and inventions to those in need and make sure they are affordable. That's another challenge that we have to accept. That the kind of machines that we can buy in this country, that we can afford in this country, may not be affordable to other nations. So the next video, again from Engineering World Health, will show you that a student team has accepted this challenge. They accepted the challenge of coming up with a solution for people who are living in a different setting. And I'm showing you this video because this takes everything one step further. This is going beyond fixing the equipment, beyond repairing the equipment, beyond translating the manual. And don't get me wrong, those things have huge effects on people's lives, literally huge effects on people's lives. But this team also said, okay, we're going to invent something from scratch to actually address these needs. So the way this program works, before we move on to the video, is students go and live in these countries for months. They learn the language. They actually stay with a family. And they work at the hospital, repairing things, fixing things, teaching other people repair or fix things. And then they also pick a problem, and they come back and they do a senior design project in order to create, in order to invent a new device, a new solution that does not exist at the moment, but will address a medical need. So I want to present to you this team, again from Engineering World Health. And give me a moment to bring up the video, please.
My name is Reese Stevens, and I'm the president of Texas Engineering World Health here at UT Austin. This past summer, I went to Rwanda with EWH and worked in a small local hospital in rural Rwanda. And there I noticed there was a huge problem where there were over 400 patients, but only 5 patient monitors. And this meant that surgeries couldn't happen on time, people weren't getting the care they needed, and these patients desperately need monitoring. So this is the motivation for our project to design a low-cost, affordable patient monitor for people in developing countries.
So, in order to make medical devices more accessible to countries in the developing world, you need to make them more low cost. And so what we're trying to do here is develop a patient monitor that is not only affordable, but that's also sustainable and reliable and can be used long term in these countries.
So our project consists of 2 main components, a central microcontroller and then 2 medical probes, an ECG probe and an SpO2 probe. Now,
I apologize for this. It seems like this is buffering.
This data is output to a 2.8-inch touchscreen, so this means that it's really intuitive for the user to interact with the data. Now, we're designing this project to be able to handle low power.
Sorry about that. I don't know why this is happening. Might be a problem with the internet connection. I apologize for the inconvenience. I'm hoping it's gonna come back soon. Let me pause the video and address this problem. I apologize for the inconvenience.
Probes, an ECG probe and SpO2 probe. Now, this data is output to a 2.8-inch touchscreen, so this means that it's really intuitive for the user to interact with the data. Now, we're designing this project to be able to handle low-power resource environments, so it has backup battery, and also rugged use environments, so it's got a plastic case we've 3D printed using some of the resources that are here on campus.
Over the past 6 months, we've worked long, hard hours to come up with this product. And I really do think that we've come up with something that's not only, acceptable for third world countries, but extraordinary. And it could be utilized in first world countries too. I think we've exceeded the expectations of what's possible. We're just college students, and we've developed a world-class product, and I hope you enjoy it. Thank you.
Here at UT Austin, we have a motto that what starts here changes the world, and we truly believe that our project has the capability to change developing world healthcare for the better. Hopefully, after reviewing our submission, you agree with us that our project has the capability to change this for the better, and with your support, we're going to make this a reality.
Now, one of the results of any disciplined effort is you start by solving one problem, and you actually end up with doing more good than you even intended. I've seen this happen with many projects, not just projects from Engineering World Health, but when engineers set out to solve problems, they start with one thing, and usually the solutions that they come up with on the way, not just one solution, but the multiple solutions that you come up with on the way, have effects on different kinds of problems. And your peers might see different solutions in the suggestions you make. That's why also teamwork in a socially responsible way is so important. And it's so important to work in diverse teams that bring in different perspectives. Now, these students set out to solve a problem for the developing world, but as you've seen at the end of the video, one of the students actually said that, you know what, this actually might also be used in the developed world. So my last message to you as socially responsible engineers are, your social responsibility does not start upon graduation. We have a social responsibility as citizens and a greater social responsibility as engineers, because like I said, we understand the technology and the science so well that we do have the responsibility to translate this technology and science in socially responsible products and solutions. And for you right now, do not underestimate your power as students. You can start changing the world right now, and you can start inventing now. Now with that, thanks for joining me in this topic of socially responsible engineering, and I hope you enjoyed it. And please let me know if you have any questions. I'm happy to connect if you want to discuss anything in this lecture further. With that, I wish you a pleasant time for the duration of this class, and I will see you in the next lecture. Thank you.